Trigonometric word problems cause students issues. So I'm going to do one more problem working with word problems. All right, last problem. All right, so each step of a stairway rises 14 centimeters. All right, rises 14 centimeters. Each step of the stairway rises 14 centimeters for a tread and has a width of 28. All right, so it goes across 28. So it goes across twice as long as it is high. And then this says, what size angle does the stairway make with the floor? All right, so this is your stairway right here. All right, so what's the angle with this stairway makes with the floor? So let's identify this angle right here. Let's say that that's what they want. All right, so that's the stairway. What size does the stairway make with the floor? All right, so let's go for that angle right there. All right, so what we're going to have to do here is understand that this angle here will assume that that is a right angle. That's a 90-degree angle. So what we're going to do is we're going to figure if this, actually let's do it, we could do it in a couple different ways. Let's say that these lines are parallel. These lines are parallel. And if these lines are parallel, this angle is equal to this angle because of alternate interior angles. All right, so let's go through the process. Let's go through the process of finding this angle and knowing that if this angle is equal to this angle, all we have to do to get this angle is find that one, and then we'll be done. This is one approach. All right, so what we told you last week is if you don't know the angle, you could use inverse trig functions. All right, so if this is the angle in question, that's the angle in question, this angle here is the opposite. This side here is the opposite side. This side here is the adjacent side. When you have an opposite side and the adjacent side, you got to use a tangent trig function. All right, so we're going to use the tangent of the unknown angle, and again, I want to make it clear the angle is unknown here, is equal to the opposite side of 14 over the adjacent side, which is 28. And what we told you last week is when the angle is unknown, you had to use an inverse trig function. So you're going to take the inverse tangent of both sides. You're taking the inverse tangent of both sides. You're going to get the angle theta is equal to the inverse tangent of 14 over 28. The inverse tangent of 14 over 28. So what I'm going to put in the calculator is the inverse tangent. All right, so I'm going to go second tangent. I hit the second key in the tangent, and I don't know if you can see it, but that says tangent to the -1. All right, tangent to the -1 of 0.5, you put that in the calculator, and you get theta is equal to 26.56 degrees. So this angle is 26.56 degrees. All right, 26.56 degrees. All right, so if you want to go mastery level, if you want to solve the same problem in more than one way, you could figure out what this angle is. Let's call that alpha. All right, so if you wanted to, let's get rid of this theta. I don't want to confuse you. What you could do is if you wanted to get this same answer in more than one way, you want to get this angle here, you could view this as the opposite, and this is the adjacent. You have opposite and adjacent again. You could say tangent of alpha is equal to 28 over 14. Again, you don't know this angle. All right, so you don't know this angle. So you could say the inverse tangent of both sides. You end up with the inverse tangent of 28 over 14. The inverse tangent of 2, you put that in the calculator. You get 63.4. All right, so you get 63.4. Alpha is equal to 63.4. Well, if this is 63.4 and you want this angle here, and both these angles add up to 90, you'd have to make that assumption. You could subtract 90. You take 90 minus the 63.4. Okay, all this is 90, and this is 63.4. To get this theta here, you take 90 minus 63.4. Theta would be 90 minus 63.4, and then you'd get theta is equal to the same 26.56 that we got before. All right, mastery level understanding. All right, so I hope that's clear. All that is a review of what we talked about last week. All that is a review of what we talked about last week. If you have questions on it, call me at 7:30. If you have questions on it, call me at 7:30. Now what I want to do is move into another topic. Another topic, all of the, oh, by the way, let me show you something. Let me show you something real quick. All right, so what I want to show you is all of these problems had a right angle. That's a right angle. You had to assume that that problem had a right angle. You had to assume that this problem had a right angle. You had to assume that this stair, that was a right angle. This is a right angle. You had to make that assumption, but every problem that you experience, unfortunately, won't have a right angle. So what I want to do is I want to talk about another topic within the subject, the umbrella subject of trigonometry that you'll experience. Topics where they require your understanding of something called the law of sines and the law of cosines. All right, so we have the sine of 35 over 6. The sine of 35 over 6. Forgive me. All right, so we have the sine of 35 over 6. All right, and then we have the sine of c over 10. All right, sine of c over 10. All right, so now we're going to cross multiply again. So we have 6 sine c is equal to 6 times the sine of c is equal to 10 times the sine of 35. All right, so we're going to divide now, trying to solve for this c, divide by 6 on both sides. Let's divide by 6 on both sides. We get the sine of c is equal to the result of this. So we have 10 times the sine of 35, and that divided by 6, and we end up with 0.955. All right, so here you don't know the angle. Here you don't know the angle, and we talked about that. When you don't know the angle, what we're going to do is we're going to use the inverse trig function. We're going to use the inverse trig function. So I'm going to take the arc sine of both sides, taking the arc sine of both sides, that'll get rid of that sine, and I'm going to take the arc sine of this side here, arc sine of 0.955. You put that in the calculator, arc sine of 0.955, and you end up with something, c is equal to about 72.7. All right, c is equal to 72.7. So this angle is now 72.7. This angle is now 72.7. But our original problem, I really wanted to solve for this leg right here. I really wanted to solve for this leg right here. And I want to make it clear that we're not done yet. And I also want to make it clear yet that we do not have a 90-degree angle. We do not have a 90-degree angle, so you cannot use opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. None of this applies unless you have the 90-degree angles that we talked about. And we do not have a 90-degree angle in this problem. So you've got to resort to this idea of a law of sines. The law of sines, again, we ask you to use a law of sines when we have an angle and the side opposite. We have an angle and the side opposite. All right, we have an angle and the side opposite for this particular problem here. All right, so now what we can see is what we have. We want this side right here. So what we can do here is figure out this angle because we've got two angles, and you may have learned that in geometry, the sum of the interior angles on a triangle add up to 180. So if we add this 72.7 to the 35, all right, and then we subtract that from 180, that'll give us this third side, which is 72.7 72.3. 72.3. All right, 72.3 degrees. Now we can get this side right here because we have an angle in the side opposite. All right, so let's proceed with this problem. We have the sine of 35 over 6. We're using the law of sines again. The sine of 35 over 6 is equal to the sine of 72.3 over this leg that we wanted from the very beginning, over b. All right, now the reason why I can use the law of sines here is because we have an angle and the side opposite. I could have, if I wanted, I could have said the sine of 72.7 over 10 is equal to this. I could have done that as well, but I just chose to use the 35 again. All right, you're going to get the same answer either way. All right, so let's cross multiply. We get b times the sine of 35 is equal to 6. B times the sine of 35 is equal to 6 times the sine of 72.3. All right, I'm solving for this b. I'm going to divide both sides by the sine of 35. Divide both sides by the sine of 35, and I get b is equal to the result of this. All right, so I have 6 times the sine of 72.3, all right, and that's going to be divided by the sine of 35, and we end up with b is equal to 9.97. This b is equal to 9.97.